Now, our topic this time really relies on us knowing what a curve does and being able to uh, look at the graph, be able to tell whether the curve is increasing or decreasing, what's its gradient, and be able to put that together with some functions and back that up with functions and being able to prove where our gradient's positive, negative, or zero. So if we have a look at a graph here, we've done a lot of work with these types of graphs, and at different points we know the gradient's doing different things because the gradient changes. The curve's not a straight line, so the gradient's not constant. So if we look at the first one here, where at A the curve's rising, so the x value as x gets larger, the y value is increasing, so it would have a positive gradient. At B, it's neither rising nor falling. If that's the case, then it must have a gradient of 0. So, and we always know that's where it's going to have a horizontal tangent. At C, the curve's falling, so it's going to have a negative gradient. At D, again, it becomes stationary. It's falling, but it stops falling for an instantaneous point, and then it starts to move down. It keeps moving there. So we're going to see that our point there would be stationary and have a gradient of 0. At E, though, it's falling again, so it's going to have a negative gradient. F, it's stationary again, so tangent's horizontal, and it's going to turn and go back up and get the point and be at the point G where it's positive. So positive gradient. So that's what we're starting to look at. Where is our curve increasing, decreasing, stationary? So that's what it starts to talk about. And what we want to do is start to put values to that. So we need to have our language down. The word increasing, the word decreasing, and stationary. What does it mean in terms of the mathematics? So if a curve's increasing, it has a positive gradient. If it has a positive gradient, then the first derivative is greater than 0. If it's decreasing, it's got a negative gradient, and our first derivative is less than 0. And if it's stationary, so it's neither rising nor falling, it has a 0 gradient. So we put our first derivative equal to 0. And that's the process we're going to do a lot, especially this one. We're going to set our first derivative equal to 0. So let's have a look at an example. So we know the general situation. We can look at a curve, but we also need to be able to do it when we've got a specific function, and we know that what the function is in terms of its definition here. So the function is defined as x squared minus 5. So show it's decreasing when x is equal to 1. So to show it's decreasing, we need to get our derivative. So we find our first derivative, and that's 2x. So it's not a hard derivative there. And when x is equal to minus 1, 2 lots of minus 1 is equal to minus 2. So if it's at x is equal to minus 1, the gradient is equal to something that's less than 0. So it must be decreasing, because the first derivative is less than 0. So if show the function's increasing at 2 minus x squared, at 2 minus x, it's increasing at minus 3 and decreasing at 4. So again, we have to get our first derivative, because the first derivative tells us whether it's increasing or decreasing. So when x is equal to minus 3, the function of minus 3 would be minus 2 times minus 3, which gives us a gradient of 6, which is greater than 0, which means it must be increasing. And the derivative of the function is equal to 4. Minus 2 times 4 gives us minus 8. And because minus 8 is less than 0, then we know it's decreasing. So the first derivative is less than 0, it's decreasing. So it does really make this very important to understand what does increasing and decreasing mean, because it doesn't say show that the first derivative is less than 0 or greater than 0. So consider this function. A little bit harder, but not too hard. 2x cubed minus 5x squared plus 7. Show the gradient's positive when x is equal to 2 and negative when x is equal to x is equal to half. So we get our gradient function. So we derive 2x cubed becomes 6x squared, 5x squared becomes 10x, 7 derives to 0. And at x is equal to 2, we sub it in. We get 4, which is greater than 0, so the gradient's positive. And x is equal to a half. we get 6 times the minus a half all squared minus 10 times a half gives us minus 3.5, which is less than 0, so gradient's decreasing. So we've got a negative gradient here, positive gradient. So positive gradients are increasing, negative gradients are decreasing. We've got to remember that, as well as the idea of the gradient being equal to 0 would make it stationary.